In this demonstration, I'll show you how to utilize EnSight's line integral convolution algorithm to visualize vectors on a surface. The line integral convolution algorithm is a unique flow visualization tool that allows you to texture a surface part with a vector. I've already loaded in a model and have colored the parts to reflect the static pressure on the surface. I'm going to select the parts where I want to apply the algorithm and access the color palette. I'll go to the Surface Flow Visualization tab and edit the properties. The variable chosen must be non-zero at the surface. If it is 0 at the wall, as is the case with velocity, EnSight allows you to offset a variable onto the surface. Since the shear stress is non-zero at the wall, no offsets need to be added, and I can visualize it by selecting the Show Flow Texture option. There are also other visual settings that can be adjusted to affect the display of the texture and the streaks. The density setting increases the number of streaks on the surface and typically has the largest effect on the visual quality of the texture. The texture created by the algorithm is not analytical. It is primarily a visual tool that is akin to something like tufts in a wind tunnel. Note that when a zero vector on the surface is textured, it will display noise on the surface. I want to also use this tool for the velocity, and since the velocity at the surface is 0, I'll edit the velocity variable and offset it onto the surface. Selecting an offset of -0.01 is large enough to represent the velocity vectors on the surface for this case. I've created a clip plane through the center of the aircraft that depicts the velocity of the surrounding fluid. I can study the flow irregularities, such as vortices, by texturing this surface using the velocity variable. I've added in a vector part showing the velocity offset onto the surface of the aircraft, and a vector part showing the velocity on the clips plane. Using both features together provides an informative visual of the behavior of the fluid in contact with the model. This concludes this demonstration showing how to utilize EnSight's line integral convolution method for fast flow visualization on a surface.